Okay, today we're going to talk about the AP1000 reactor from Westinghouse and the reliability that it provides. So one of the key features of this reactor is that it utilizes passive systems versus active systems. An active system requires operator action or the use of equipment to start or some kind of action for it to provide its safety function. Whereas passive systems just use laws that are 100% reliable. They're not any electricity function. It's just they're guaranteed to work. So as I mentioned, active systems require operator action. It's not as, the redundancy is not built in there, whereas the passive systems, rely on Newton's universal law of gravitation as utilized in the AP1000, natural convection, just stuff that's guaranteed to work. So a lot of active systems, we build in redundancy in our nuclear power plants. Well, at some point you get down to where there's only one electrical bus or there's only one pump. There's some single point vulnerability. So it really doesn't do as much for you as implementing a passive system by more active systems. So another key aspect for the AP1000 is that all your makeup water is already stored in the containment building. When we had the Fukushima incident in Japan, they were using salt water, just getting it from the ocean. Basically, the AP1000 houses enough water inside a containment building to keep it cool when they have a station blackout for 72 hours. Most of our plants now are designed for about a 4-hour blackout scenario. But the feature of the AP1000 is that they can go 72 hours with no electricity and everything being perfectly safe and no harm to the environment. So one of these passive systems they utilize is the containment spray system. So basically what happens is you have makeup water inside the containment. As it heats up, it is going to rise to the top as it steams off, and you get natural airflow through the outer containment that will cool off that steam inside, and basically you'll get natural condensing inside the inner containment building with the airflow and the water dripping on the outside of that inner containment, which is all gravity fed. Another key feature is that the reactor coolant pumps do not use shaft seals, whereas some of the older Westinghouse pumps actually have a leak off. So you're constantly losing your primary coolant out into a tank. It's perfectly safe, it's perfectly designed to be like that. But the can motors just take away that that chance where when we lose power, you don't have a slow leak in your coolant. Another great feature about passive systems is they require less valves, which requires less contamination, less work. It's cheaper. Basically, there's less places that the systems can fail. So the other good part about this is the construction reliability. There's one design. They say it's from turbine to toilet. Every plant's going to be the same, whereas every Westinghouse 4-loop design from the 70s, they're different wherever. Different people built them. They can have a different steam system on them, away from the primary system. So there's no need for resubmitting designs. Everything is guaranteed to work. If they come up with an issue, it'll be solved fleet-wide at every single plant. So all the maintenance can be easily tracked, and basically there's just a better communication amongst the industry. So really, these AP1000s are really a good method of obtaining electricity and having a diverse platform in the future. So look forward to seeing the completions of them down in Augusta, Georgia, and hopefully more people will start building them.